Hello, and welcome to a video walkthrough of Chapter 5 questions. And we're going to do the math problems. I'm going to start with question 15, which gives me 4 wall elements, and they list my elements. And then they say, using the table on 5.2, how many BTUs per hour per square foot will be lost through a wall if the outside temperature is 50 degrees Fahrenheit. So now reading this problem, I can pick out the equation. And so I'm going to use my C over T is equal to my 1 over my R times my area times my change in temperature. So that's going to be my equation. And now I'm going to look up my R values. So I put the page in here so that we can find them. And some of the material is the wood siding, which is down here, and fiberglass insulation, sheetrock, and plywood. And I'm going to sum these all together because we have to remember to sum all our R values. And so I'm going to add all of my numbers, and when I do that I get 12.78, and that's in my R value units of feet squared, hours, degrees Fahrenheit over a BTU. So I'm going to bring that number over to my question. And I'm going to set up my problem. Now, the problem is telling us to do a foot square in our area, so we're just going to do it by a foot square. And so my area over here will be 1 foot square. So it's 1 over my 12.78, and that's my unit of feet squared, hours, degrees Fahrenheit, BTU, times my area of 1 foot squared, and my change in temperature of 50 degrees. As far as units go, I can cross out the feet squared and the feet squared, the degrees Fahrenheit and the degrees Fahrenheit, and I'm going to beat the BTU change in the hour for my outside temperature. So I'm going to get BTUs per hour. So when I plug in, do this part first, my 1 divided by my 12.78 times 1 times 50, I get 3.912. So if I want to have some extra units, I can put 1, 2, and that is BTUs per hour. All right, so that's how you do question 15, and I'll be back in a moment after cleaning up my page for question 16. Alright, so question 16, heat loss through window is substantial. What percentage savings will be gained by covering a double pane window with 2-inch sheet of rigid polystyrene board? And so I'm going to go and find my information that I need for my R values. And my polystyrene board is 1 inch at 4 for the R value. And my insulated window, or my double pane window, is 1.72. So my polystyrene board is only 1 inch, so I've got to double it for 2, and so my board is going to be 8, and my insulated window, my window, is going to be 1.72. So now let's go back to the problem. For the problem, we're not going to be using this standard equation, we're going to be doing a percentage equation, and so I'm going to take my high number minus my low number and divide it by my total high number. And I should get my answer there. So what I'm going to do is take my combination of my window with my polystyrene board, since I'm putting them together. So I'm going to do my 8 plus my 1.72, which would give me 9.72, and that's going to be my high number, minus my low of 1.72 divided by 9.72. So when I subtract this first, I'm going to get 8, and when I divide by my 9.72, I get 0.82%, which if you times by 100, you get the percentage, so I get 82%. But I'll also take the 0.82. So it's your call on how you want to do the difference. So question 16. Okay, so question 17 is where we start to play with an entire house. and they give you an old house built in 1858. It's constructed in 2-inch hardwood planks, plus a 1/2 inch of lap wood siding, sheetrock, covers the inside of the dwelling. The size of the house is 28, 40, 10. For simplicity, assume the floor is flat and covered with 1-inch plywood, plus asbestos shingles, and has 3.5 inch of fiberglass insulation. There is a wood subfloor, and they're telling you the size of that in the attic, and a hardwood floor of 3/4 of an inch over an unheated crawl space, assuming 25% of the wall areas are single pane windows. The outside is 40 degrees Fahrenheit colder than the inside of the house, so they're giving you a change in temperature. So this one is a QC over T. So this is the equation for this one. This one's a QC over T is equal to the sum of all my 1 over R's times areas times a change in temp. So that's going to be our equation that we're going to use. But because there's so much information here, I am going to tell you that you should take time to add up all your R values for each piece or each component of the house. And then we'll do our areas. And our areas will be 28 feet, 40 feet, 10 feet. So our standard setup of size on our house is that these are going to be 10 feet tall here, and this is going to be 28, and this side's going to be 40. So that'll give us what areas we need to work with for each number. And so I'm gonna flick to the next page and start to look at my R values and add up things like my walls and my windows and my roof and so on and so forth with all of these pieces. Alright, so for the sake of time, I took each piece and added them up. So for all the information of everything that they gave me for walls, I put that information together and summed it so that I'm getting an R of 3.08. The roof, I get 12.8. For the floor, I'm getting 1.66. And the windows, since they're just single pane, is just the 0.88 for the looking up. Now comes the tricky part, and this is where I have to take into the account of the equation where I'm doing the sum of all my 1 over my R's times my area. So I'm summing up each piece, and I'm going to do them all separately because each one has a separate piece. So for the walls, I'm going to do my 1 over my R value, of 3.08. But this is all going to be times the various areas that I'm going to get. So for my walls, 2 of the walls are going to be 28 by 10, and 2 of the walls will be 40 by 10. So I'm going to do 2, this is all going to be times by 2 at the end, times the 28 times 10. And I'm going to do this first to get my area in feet squared. And that will be summed, so added to the 2 to the power over 3.08. And that's going to be times my timesing of my 40 by 10 feet to square my feet. And so that'll give me my total for my information of areas and R values. And because I'm not doing my change in temperature yet, so I haven't done my change in temperature yet, the first part of my answer will come out to be in BTUs, hours, degrees Fahrenheit, but the feet squared are going to cross out. Alright, so now to continue on with the question to add to it, I did my wall setup, and depending on where you rounded, your number might be bigger down here. So your number might be bigger. The next part is, in the question, they tell me that 25% of the walls are windows, and so I have to say that 75% of my walls are not windows, or this BTU that I'm working with. So this is my 75%, and then I'm going to do my change in temperature, which means that my feet, or my degrees Fahrenheit will cancel out, and I'll have BTUs per hour. And when I do this, depending on where you round it, and so the numbers can vary, and I said you can be off by a couple hundred BTUs, and it's okay. The numbers that I get range between 13,247 BTUs per hour, all the way to about 13,056 BTUs per hour. And I'll take anything in that 5-6, sorry, and I'll take anything in this range. And that's basically how you would consider calculating heat loss for different numbers. And this gives me my number for BTUs in the case of the walls. So this is my walls only. So now we're at that time where I don't have much more space in my video, so I'm going to actually stop. I did provide you an answer key online, and I do hope that this getting started helps. It helps you see all the little intricate pieces needed. Obviously, a question like this and more questions like this is something that we wouldn't tackle in this course, but in a thermodynamic style course or in an energy home analysis course, you would tackle these questions and really spend some time on them. And so I do hope you're seeing how I get to my answers. Hope this helps. Ask questions. Bye.